So we mentioned perception of drought, excuse me, meteorological drought, agricultural drought, and socioeconomic drought, and so on. And there is also a combination of human impacts and natural variability. So when we looked at El Nino, we talked about the teleconnections of El Nino and La Nina that are seasonal, seasonally dependent, and so on. This is nice work by Trenberth and Dye out of NCAR, and what this is showing is a so-called Palmer Drought Severity Index. I won't go into the details, but basically uses temperature and soil moisture and rainfall and so on. Not everybody agrees whether this is the best index. There is other indices as well, but for the purpose of pedagogy here, for making the point, this will serve well enough. So what this is showing is a PDSI map and the time series of that map for the globe. So you can see that the red colors are where there are severe droughts, and there are wet regions as seen in positive PDSI numbers. So you can see that the indication here, when you look from 1900 to about 2005, which this analysis went to, it seems like from 1940s onward, the worldwide drought seemed to have increased. So there was some up and down here, but especially since the 1980s, PDSI has remained positive as a whole. Of course, as we said, drought is very local as well, but nonetheless, overall, there is a desiccation of the planet in terms of the Palmer Drought Severity Index. What does that mean? Basically, again, it's consistent with the redistribution of rain and changes in rainfall seasons as well, with durations of droughts getting longer and more frequent, and rainy regions getting squeezed with heavier rain. And you can separate that further using the so-called empirical orthogonal function, which is a way of doing statistical analysis. When you have a time series with spatial dimension like latitude and longitude, and time dimension because you have time series of rainfall and other quantities at each location on the planet, then these empirical orthogonal functions split that time series into dominant patterns. So the most dominant pattern here is explaining 6.7% of the total variance in the signal of Palmer Drought Severity Index, should be PDSI. And the second EOF is explaining about 5%. Each of the pattern has a time series associated with it. So if you multiply at any given location, if you multiply the value in the spatial loading with the time series, you get the time variability at that particular location. So it's a very neat, compact way of representing patterns and time variability. And you can see that this is similar to the PDSI that we saw here. So the first mode of the PDSI EOF is explaining the climate change part of the drought severity index over the period of 1900 to 2005. And beautifully here, the second mode captures essentially what is an El Nino mode combined with something like a PDO, or the Pacific Decadal Oscillation mode. In other words, you see here there are decades where the PDSI is above zero line, the long-term average, so it's drier globally and wetter here with some spikes in the middle. Almost each one of them correspond to El Niños, 82, 83, 97, 98, and so on. But droughts can straddle across El Nino events and so on, especially over regions like California. Sahel had a drought that lasted for many decades, and so on and so forth. Okay, so this decadal and El Nino timescales mixed in here tell you that this is the natural variability part, has ups and downs about the zero line, whereas you can compute a trend here and you'll see that the droughts have increased in the latter part of the 20th century, especially beyond 1980 or so, which was also seen here. Okay, so then putting this together with the meteorological, agricultural, hydrological, and socio-economic droughts, often it is said that drought is also a perception. Okay, so there is an experience that happens over a lifetime, and there is a memory built with the experience, which affects the definition of the drought itself, how severe it is, and whether it is a drought or whether it's just a delay in rainfall, for example, and so on. And that affects the behavior not only of the individuals but collective and governmental. For example, if there is a indication that a drought is setting in, based on the experience, the individual and local collective society or local government may begin to ask from the national government for assistance, which happens a lot in places like Nordeste and so on, where as soon as there is an El Nino prediction, people will say a drought is coming, so we need assistance to avoid mass migrations, abandoning of agriculture, and so on. Okay, so that is going to be having a local context in terms of characteristics and farming practices. Depends on whether it's rain-fed agriculture, it's irrigated agriculture. We will see later on how those things matter as well. And there are vulnerability factors. If you are a subsistence farmer depending on rain-fed agriculture, your vulnerability is going to be high, whereas if you have, let's say, subsidized electricity to mine groundwater and irrigate through a dry season, then maybe your vulnerability is low, and so on. So altogether, the actions to address drought by these individuals or collective action or governmental action is going to deal with these vulnerabilities. Of course, everybody wants to reduce their vulnerability. So you have extreme rain events now doing crop damage and so on, which also create lots of demands for action to protect against crops. There are crop insurances and so on that have to deal with monitoring false claims, etc., etc. So the human factor is of course involved in there. But droughts, which used to be thought of as low frequencies, have now become also somewhat of extreme events, because there are quantities called flash droughts which pop up quickly, and with the warming, the water holding capacity of the atmosphere goes up. So when there is a rainfall deficit, for example, it may be just a light meteorological drought, but the soil moisture is lost rapidly because the air is so warm and can desiccate the soils quickly and create crop stress, crop yield loss, etc. So the indirect effects of warming are going to make these things worse as well. So there are cascading effects also of drought severity versus warming temperatures, and of course population increase and more water demand for irrigation is going to add as well. Irrigation is the largest water consuming sector pretty much across the world. Sometimes it is 80% of the water use in competition with domestic and industrial use, for example, and commercial use. In India, it's almost always 80%. So water resource management then is going to critically depend on managing these perceptions of droughts and need for actions to mitigate drought, or if there's shifts in rainfall, then to adapt to losses of water resources over time.